Welcome to this deep dive. Today we're tackling something pretty central to modern software development. Test automation in CI/CD, specifically using Jenkins.
Yeah, it's a big one. If you're involved in Agile or DevOps, or honestly, even if you're just curious about how software gets built efficiently these days, this is really relevant stuff.
Absolutely. So our mission today is to really unpack this, get past the buzzwords and understand how you actually weave testing into that continuous development flow.
Exactly. We want to go beyond just the theory and look at how this practically changes things based on, well, the material we've dug into.
Okay, sounds good. So maybe let's start with the basics. CI/CD, we hear them together all the time. Continuous integration, CI. What is that really?
Right. So continuous integration, or CI, is essentially the practice where developers merge their code changes back into a main branch frequently. And crucially, each time they do that,
An automated build kicks off.
and tests.
Exactly. An automated build and automated tests are run. It's about catching integration issues early. Makes sense. And the CD part, continuous delivery or deployment.
So CD takes that code that's passed the CI tests and automates the release process. Continuous delivery usually means it's automatically deployed to, say, a staging environment, ready for a final manual push to production. Continuous deployment goes one step further and automates that final push to production too, if all the tests pass.
Got it. So CI builds and tests the pieces together. CD gets it ready to go out, or actually pushes it out.
Pretty much.
And the big win here, what do our sources say are the main benefits?
Well, there are a few consistent themes. Less manual drudgery, definitely. You're not manually building and running basic tests over and over.
Right, save time.
Huge time saver,
Yeah.
which leads to faster releases, getting features and fixes out quicker. And maybe most importantly, finding bugs much, much earlier, like almost immediately after they're introduced.
Yeah, that early detection seems critical. I think one source mentions something like a 30-40% drop in bug fixing time.
Yeah, figures like that pop up. When you catch it right away, the context is fresh. It's just way easier to fix.
It really drives home that it's not just about speed, but quality too. Someone used an analogy, like an automated car assembly line.
Oh yeah, I saw that too, where each part is automatically checked before it moves on, ensuring the final car works. It's a good way to picture CI/CD, I think.
It is helpful. So if CI/CD is the assembly line, what runs it? That's where Jenkins comes in.
Often, yes. Jenkins is, well, it's one of the most popular tools out there for orchestrating this whole process, a real workhorse in the CI/CD world.
What makes it so popular? Our research pointed to a couple of things.
Definitely. Number one, it's open source. That means a massive community, loads of support, and, no vendor lock-in.
And the plugins. I heard that was a big deal.
Oh, absolutely huge. The plugin ecosystem is vast. Whatever tool you're using for testing, for source control, for deployment, for notifications, there's almost certainly a Jenkins plugin to integrate it.
So it's less of a fixed product and more of a customizable hub.
That's a great way to put it. It connects everything. It handles the whole workflow, or pipeline, as it's often called in Jenkins terms. It watches for code changes, triggers builds, runs tests, reports results, handles deployments.
It does sound a bit like that smart home butler analogy someone used. You program it to do all these routine tasks automatically.
Yeah, like if code committed, then build, then test, then notify team. It automates those sequences.
Okay, so Jenkins manages the pipeline. But where does the test automation specifically fit? It's not just building and shipping code blindly, right?
Oh, absolutely not. That's probably the most critical part, actually. Test automation is what gives you the confidence in CI/CD. As one source put it, it's the quality backbone.
Right. Without automated tests, the continuous part kind of falls apart because you'd have to stop and test manually all the time.
Exactly. You lose all the speed benefits. Think about that assembly line again. If you had to manually inspect every single component by hand at every stage, the line would grind to a halt. Automated tests are those automated quality checks.
Okay, so let's trace it. Developer writes some code, commits it to Git. What happens next in a pipeline with good test automation?
Right, so the commit happens. Jenkins is watching the repository, sees the change, and boom, it triggers the pipeline.
And that pipeline has stages, including testing stages.
Precisely. After maybe a build stage, you'll hit one or more testing stages, and this is where it gets layered.
Layered. What kind of tests are we talking about?
Well, you typically start with unit tests. These are small, fast tests checking individual pieces of code, like a specific function, think Joe unit or testng, those kinds of tools.
Okay, the really granular checks.
Yeah. Then you might run API tests. These check the communication points, the interfaces, making sure they behave as expected. Tools like Postman or Rest Assured are common here.
So checking how different parts talk to each other, sort of.
Exactly. And then often later in the pipeline, because they can be slower, you have UI tests. These actually drive the user interface, simulating what a real user would do, clicking buttons, filling forms.
Using tools like Selenium or Cypress?
Yep, Selenium, Cypress, Playwright, those are the big names for UI automation.
So it's a whole spectrum of tests.
Yeah.
I also saw mentions of tests happening at different times, like pre-build, build time, post-build.
Ah, yes. That's about optimizing the flow. Pre-build might be things like static code analysis, checking the code for potential issues before even trying to build it. Linters fall here, too.
Catches things early, saves build time if the code's messy.
Exactly. Then build time testing is typically where your unit tests and maybe some faster integration tests run. They check the core logic works as soon as it's built.
And post-build?
That's usually where the more comprehensive end-to-end stuff happens. UI tests, definitely. Regression testing to make sure the new code didn't break anything old. Maybe even performance or security scans.
And the key is, all of this runs automatically. No one's manually clicking run tests.
That's the goal. Triggered by the code commit, Jenkins orchestrates running all these different test suites in sequence or sometimes in parallel.
That automatic feedback must be incredibly valuable for developers.
It's transformative. You know within minutes if your change broke something fundamental. No waiting days for QA feedback on basic stuff.
Let's make it concrete.
Yeah.
One of the sources used in the e-commerce example, say a developer adds a new feature, like viewing order history. How would Jenkins and automated tests handle that?
Okay, good example. So, developer finishes coding the view order history page, commits the code to the repository, maybe GitHub.
Right.
Jenkins sees that commit, instantly pulls the latest code and starts the pipeline. First step, probably build the entire application.
Okay, build succeeds, then tests.
Yep. Next stage, run unit tests. These would verify the specific logic written for fetching and displaying order history, making sure the data handling is correct in isolation, probably using JUnit or something similar.
Got it. Checks the new code itself.
Then maybe API tests kick in. Using, say, Postman scripts, Jenkins would automatically call the backend API endpoint that serves the order history data, verifying it returns the correct information and status codes.
So, checks the backend service powering the feature.
Correct. And finally, perhaps a UI test stage. Jenkins could launch Selenium, which would open a browser, log in as a test user, navigate to the order history page, and assert that the orders are displayed correctly on the screen.
Wow, okay. That covers a lot of ground automatically.
Right.
What happens if all those tests pass?
If everything's green, all tests pass, Jenkins moves to the next stage. This might be automatically deploying that new version of the code to a staging or a QA environment.
An environment that mirrors production.
Ideally, yes. And often, Jenkins will then send out a notification, maybe a Slack message or an email telling the QA team, hey, the new order history feature is on staging, ready for exploratory testing.
And this whole sequence, commit, build, unit test, API test, UI test, deploy to staging, notify, how long does that typically take?
That's the beauty of it. Ideally, we're talking minutes, maybe 10, 15, 20 minutes, depending on the complexity in the tests. Not hours or days waiting for manual handoffs.
That speed is just incredible. That rapid feedback loop changes the game for how quickly teams can iterate.
It really does. It fosters that agility everyone talks about. Find problems fast, fix them fast, deliver value faster.
Now, we mentioned a few tools already, JUnit, Postman, Selenium, but Jenkins works with a lot more, right? The toolkit seems pretty diverse.
Oh, hugely diverse. That plugin architecture means it plays well with almost anything. For unit tests, yeah, JUnit and TestNG are dominant in the Java world, but there are equivalents for every language.
And UI. We said Selenium, Cypress, Playwright.
Those are probably the top three right now for web UI automation. Each has its strengths, but Jenkins integrates with all of them.
What about API testing beyond Postman?
Rest Assured is another very popular one, especially for Java-based projects. But again, Jenkins can trigger scripts from various API testing tools.
And once the tests run, how do you make sense of the results? Just a pass-fail message.
You can get much more. That's where reporting tools come in. Things like Allure or Extent reports integrate with Jenkins. They take the raw test output and generate really nice, detailed, often graphical reports.
So you can see exactly what failed, maybe trends over time.
Exactly. Makes debugging failures much easier and helps track quality. And Jenkins itself can archive these reports with each build. Plus, notifications are key. Sending results to Slack, Teams, email keeps everyone in the loop instantly.
It also seems Jenkins integrates well with newer infrastructure trends, like Docker, Kubernetes.
Oh, yes, absolutely. Jenkins has excellent support for building Docker images, running builds and tests inside containers, and deploying to Kubernetes clusters. It fits very well into modern containerized cloud-native environments, works smoothly on major cloud platforms, too.
So it's really flexible, scales well, but just having the tools isn't enough, right? There must be some best practices for using Jenkins and test automation effectively.
Absolutely. You can definitely implement it badly. Our sources highlighted several key things. One big one is keep your tests fast, especially the ones that run most frequently.
Right, like the unit tests. If they take ages, it slows down that feedback loop we just talked about.
Precisely. A slow CI process defeats much of the purpose, so optimize those tests. Another related point is often separating fast and slow tests.
How so?
Run the quick unit tests on every single commit, but maybe run the slower, more extensive UI tests less frequently, perhaps nightly, or only on merges to the main branch, or run them in parallel.
Parallel execution. That came up too. Running multiple tests at the same time.
Yes. Jenkins makes it relatively easy to set up parallel stages or distribute tests across multiple agents or machines. This can drastically cut down the total time for a large test suite.
Makes sense. What about organizing the pipeline itself?
Using stages in your Jenkins pipeline code is crucial. Define clear stages like build, unit test, API test, deploy staging. It makes the pipeline understandable, visualizes the flow, and helps pinpoint failures.
Good structure. And managing the results long term.
Archiving test reports is important. Don't just look at the latest run. Keep a history. It helps spot flaky tests or regressions over time. Traceability is key.
And the fail fast idea.
Yeah. Simple but powerful. If your critical unit tests fail early in the pipeline, stop the build right there. Don't waste time and resources running slow integration or UI tests if the basic code is broken. Fail fast, fix fast.
That seems logical. There was also a pro tip about test data. Why is that so important?
Test data management. It's often overlooked, but it's critical. You need clean, reliable, consistent test data for your automated tests. Bad or inconsistent data leads to flaky tests.
Flaky tests. The ones that sometimes pass, sometimes fail, for no obvious reason.
Exactly. And those are terrible because they destroy trust. If people don't trust the test results because they're flaky, they'll start ignoring real failures. So solid test data strategy is essential.
That's a really good point. Okay, so wrapping things up a bit.
Yeah.
We've seen Jenkins as this powerful engine for CI/CD, but test automation is really the crucial fuel that makes it work reliably and deliver quality.
Yeah, it's the automated quality gatekeeper throughout the whole process, giving you that confidence to move faster.
And the benefits seem clear speed, reliability, finding bugs early, that rapid feedback.
Absolutely. It shifts quality checking left earlier into the development cycle.
So for you listening, if you want a tangible next step, maybe try setting up a really simple Jenkins pipeline, even just one that automatically runs your unit test every time you commit code.
That's a great starting point. Just experiencing that immediate feedback loop, even on a small scale, can be really eye-opening. See how it feels, how it changes your workflow.
Yeah, get your feet wet. And maybe a final thought to leave you with. In this environment where speed and quality are paramount, can development teams really afford not to embrace this kind of automation? It feels less like a nice to have and more like a fundamental part of building software effectively today.
I tend to agree. It's becoming table stakes for staying competitive and delivering consistently.